He graduated from the National University School of Architecture in 1974. And as the firm's creative leader, Jonathan has led the firm's major institutional, community and award-winning projects, including the Fort York Visitor Centre, Senator O'Connor Estate and Coach House and Ireland Park. Jonathan is a passionate advocate of the Passive House standard, and you'll see from the slide on the screen has been involved in a number of Passive House projects. And tonight he will present his Interfit Reach Guesthouse project. So I think that's going to be really interesting. Before I hand over to Jonathan, if you could just put any questions throughout the presentation into the chat, and I'll do my best to collate, field and order them once Jonathan has finished speaking. But I would encourage everybody to get their questions in there, however simple they think they may be. It's always good to have some questions at the end. So with that, I'll hand over Jonathan to you. So welcome.
Thank you very much, Simon. Thank you, Barry. And thank you, Yvonne, for helping me get set up here. And on the screen, we're looking at a range of the project types that we've been involved in over the last few years. And they go from small to medium to large and to extra large. And I think for all of you who know that how Passive House works, we know that the smaller the building, the more dependent it is upon its orientation and its form and the need to capture as much free heat from the sun as possible. Whereas in the larger projects, and especially in the extra large, we're mostly dealing with air conditioning or cooling because of the extensive internal heat gains in those buildings. So even though we're in a cold climate, we find the larger buildings are really about cooling. And I think we could probably be building those buildings with no heating system, and we'd still do extremely well. So I'm very impressed with the list of fantastic projects that Barry just mentioned. And, I hope you'll find it interesting to just talk about a tiny little house in Ontario, because it's really quite diminutive. And I have to tell you that both the small and medium on this slide are personal projects of mine, where I'm in this location about 2.5 hours east of Toronto along Lake Ontario. And both properties are waterfront facing. And they're what I call my learning or laboratory projects. So the Reach Guesthouse, which I'm going to present to you, was a property my wife and I bought back in 2016. And when we purchased it, and I'll move to the next slide. Okay, that didn't work. So where do I go to change the slide?
Jonathan, just the down arrow or the left arrow, hopefully.
Oh, maybe that. Oh, sorry. Okay, I was doing the left and right.
Yeah, there you go.
Okay, so when we purchased this property, it's 10 acres with 800 feet of waterfront. So everyone said, well, when are you tearing the house down? Because everyone reckoned there was nothing to save here. And, at first glance, you might agree, but I thought maybe I'll start to tear it down, but a bit at a time. And so I happened to have a friend who was a temporarily out of work sculptor, and he and I started into the house to strip out the plaster and begin to see if there was anything worth keeping. And the more we took the interior finishes away, the more we started to like the house and to see that this was an 1890s post and beam farmhouse. probably using old growth white pine timbers. And it was all in very good condition. And in spite of being quite worn and having been renovated over and over again, we got to like the feeling it was giving us. And you can see where the lath and plaster had been taken off here. And then parts of the floors had been painted and some had linoleum. The linoleum is in the right picture here, gradually delaminating. So it was in pretty rough condition, but my artist friend picked parts of the fit up and saved them, and saved all the doors and the door handles. And we gradually put those all back in. So what we reached a point where we said, okay, we're not tearing this house down. We're going to preserve it. So it became a kind of a heritage project. At the same time, it became an archaeological uncovering and delayering process. And then it became a passive house EnerFit project. So here's a view up on the second floor, which is, and this house is, there's hundreds of this house type in Ontario. It was a very common build, and it was almost like a standard pattern for a house that you would find around rural Ontario. And down in the basement, you can see that even the beams supporting the main floor of the house were just hand-hewn, not even fully dressed beams, but half timbers. And so we reached the point where we said, okay, we can clean and fix and repair the inside and take a house that was fully plastered and in part drywalled as well, and strip all of that out and see if there was a woody structure in there that we could use. So from the point of view of not tearing it down and keeping an existing building, that was the first step in sustainability, but also it being a wood structure where it had a very low energy embodied content already. And then we found a local supplier of SIPs, structural insulated panels, who was building them with OSB skins and expanded polystyrene cores. He built them for our walls and for our roofs. And so he only had to transport them from about 15 minutes away, and he had built them all in sections in his shop. So we were interested in keeping the kind of heritage or original feel of the house. And that's why we took the porch, we braced it and reinforced it and pulled it away from the house so the SIP could go down the full length of the front facade. And then we put the porch back and just clipped it to the exterior of those new SIPs once the wood siding had gone on. There's the original window in the gable, and we added about 2.5 feet of height to the building so that we could fill the roof space with cellulose insulation, which gave us about an R70 thermal resistance value in the roof. And the 12.25 inches of ESP in the wall SIPs gave us about an R43 effective. Now, I know you think and work in U values, which I'm less accustomed to using, but this is an exceptionally high level of insulation, and higher even than we need in this climate zone. Here's a view of the jacketing process. So we're looking along the ridge of the original house here, built around 1890, and we have covered and enclosed the entire building in a vapor barrier. and then installed the wall SIPs, and then supported a new roof in a truss form over those SIP walls. So we basically put a big overcoat over the whole house. And the rear portion of the house was a low single-story, very poorly built addition, maybe built sometime in the early 50s. It was so badly built and it was in such poor condition, we removed it down to the top of the foundation walls. And then we put a more generously scaled new structure, which was one continuous frame back in its position. And we treated that in a more contemporary manner, so as to contrast somewhat with the existing building. So as we get closer to the house shaping up and getting ready for its siding, this is the way it started to look. And there's the original concrete block foundation walls of the rear portion. The windows are all vinyl windows, triple glazed, not pH certified, but very high performance in terms of the energy modeling that we had done on them. They're from a company called Intus, and they supplied the windows and doors. So we only have two doors in the house, a front door and a back door. And otherwise, we respected all the window openings of the original house, except that in the front of the house, we made the gable window to suit the new shape of the new gable and oversized it a bit so that eventually you could see the original house inside the new house. It's like house within a house. And there's the porch put back in place, and we built a new deck, which kind of allows the house to sort of float in the landscape. And it took on an almost surreal look by making it all white, which contrasts with the original house. But I felt this gave what started out as a very modest renovation became something that we were all feeling quite happy about. And the contrast between that kind of incessantly white outside and the inside then became even more interesting. But let's look for a minute at the strictly speaking passive house aspects of this. Our SIP supplier was also the agent for Jablotron, which is a Czech Republic-based manufacturer of ERVs. And this was their early product. We only borrowed this because we were waiting for a shipment of their newer unit, which is called the Futura, which is currently what's in the house. But this guy went in, and when the Futura unit arrived, we just unplugged this one and plugged the Futura unit in. So this is in a utility room on the main floor of the house. And of course, you're probably all familiar with drawing the red line around the enclosure of the treated area without lifting your pencil. And that was pretty easy to do in the upper part of the house. But when you're renovating and you're dealing with existing structure, there's always some places where it's very hard to get a continuous air seal. And the biggest challenge here was that we had 4 major posts, one in each corner of the house. And then we had plank columns with board and batten cladding going up and down the walls. So what we had to do was a bit like the process required in underpinning. We had to get an air seal going around between the floor and the outside of the wall. So we had to prise out the board and batten on a progressive basis and put a wrap of blueskin going from inside to outside, going down under the board and batten and up on the outside. So when we put our air barrier wrap around the whole house, we were able to seal it on the outside here, bring it all the way around and down on the other side of the building. And then to get an airtight seal across the floor, we had to lift up all the floorboards, exposing the subfloor, and then put down a layer of OSB, which gave us an airtight seal, and sealed that to the blueskin, and then put all the floorboards back down again, basically in exactly the same positions that they had come up. And all of that is sitting on, the whole structure sits on these perimeter beams, which are about 7 inches by 9 inches, and they sit on a 30-inch deep stone wall, basically made with stones found in the immediate terrain. We're in a landscape of primarily limestone geology. So I'll show you that in a bit more detail here, because there's that 30-inch stone wall. We put EPS insulation on the outside of that wall just to keep it a little bit warmer, even though we're not heating this basement space. There's the ring beam, 7 inches by 9 inches, and we added a bearing plate here that allowed us to fasten our SIPs. So here's the pre-manufactured SIP wall coming in with, it's filled with ESP, and it has an oriented strand board or OSB skin on each side, and it's fastened in here. And there's 2 other points where it's fastened to the existing structure. From the interior of the room, you go to number 2 is the replaced finished floor, then the new 3/4 inch tongued and grooved OSB, and then the original subfloor, and then EPS foamed in insulation. So we got a specialized contractor to come in, and he foamed that insulation in about 4 layers. So the perimeter wall, then we were able to, here's the board and batten at number 6. And we were able to recess electrical receptacles and octagon boxes in there without disturbing that next layer, which is actually the old ugly stucco that was put over the board and batten at some point in the life of the house. And we didn't remove it because we thought it was unnecessary, and it kind of added a stiffness to the wall, which helped. But there's the vapor barrier going down there, fastening to the blueskin, which went under those boards onto the OSB and then gave us the continuity of the air seal. So on the outside, we finished it with a pre-finished wood siding, and that went on the SIP. Like there were battens going down the vertical face of the SIPs, and it also allowed us an airspace. And there's the existing stucco, the existing boards, existing wood columns, and then the interior space. So that was fiddly work, but at the end of the day, when we did our air pressure test, we achieved 0.5 ACH, which is half of the, well, it's twice as good as the requirement for an inner fit, which would be 1 air change per hour. And this is, the plan is very simple. You know, again, we didn't add to the gross floor area of the house. You come in a front door here, and we made a master bedroom suite here with a king-size bed and a living space here. Here's the original stair to the 2nd floor. And then this is the part of the house we rebuilt with a new kitchen island, and a utility room with an insulated access hatch to the basement, which is really a cellar now, because all it has down there is the well pump and a 1,000-gallon water cistern. On the second floor, you can see the open to below of that tall room and the upper part of the utility room, and then a completely enclosed bedroom and a second bedroom that's an open plan with a bathtub, sink, and WC. And we opened up a space in the floor here, so you could, as soon as you came in the door downstairs, you could see right up into the roof space, and there's the stair going down. So again, reverting back to what we were talking about earlier with the whiteness of the outside and the nice rich color of the wood, we really like that here as well. So we didn't finish or put any soffit into the porch as it had at one time. And you can see we're at about 18 inches in the depth of the new walls. And a view from the northeast, showing the deck, the back, and this has become a very nice place to sit and catch a view of the lake. And a few more shots, winter scene. And there are other sheds on the property, which we may do more work on in the future. Since we finished this in 2017, we've been renting it on a short-term basis. So if you're ever visiting Ontario and you're looking for somewhere to spend the night with pleasantly fresh air and a nice cozy temperature, in our first winter, which was 2017, we had about a week of minus 25 degrees centigrade weather conditions. And the only heating I had in the house was from a small electric heater that I bought at a yard sale. I paid $20 for it, and it kept the house at plus 17 all the way through that winter, even with minus 25 outside. So to me, that was, the proof was there that I did something right. And then here's what my friend produced in the interior. He pulled every nail out of the roof. He cleaned every bit of the wood. He put back doors after he rented the equipment and sandblasted everything, and then sealed all the wood with a nice clear sealer. He found things like skis in the attic, old wooden skis that you couldn't use anymore, but which were like jewels found in the ruins of the old house. And also found this ladder, which we kept as well. And then some of the old millwork that had been built in was kept, restored, cleaned, and now we use as a linen closet. And then we use this as a bedroom. This converts into a bed, this sofa. And there's the old original window with the bigger oversized window on the outside of it. And down on the ground floor, you can see to the left here, there's a door to the staircase. I think they used to do that so that you could contain the heat more on the ground floor. There was, in all likelihood, a pot-bellied stove on this floor, and the flue from it, which would have been a metal flue, would go up through the house and wind its way through each of the bedrooms before it went out through the roof. And that really was the central heating system. And of course, there would have not been any air conditioning in this house. And so we're looking through an open doorway here from the 1890s into 2021. And you can see the ERV air supply in the top right corner there. And that's typical of one of the 4 posts that holds the house up. And the beams and wood, you can see all the hand-hewn marks on it because there was no sawmill locally available. This would have all been hand-hewn with an ADZE tool. So all of that, you know, we really enjoyed the handmade quality of the interior. I'm sorry, I went the wrong way there. Okay. A view along the top floor with the bathtub to the left, and the original banisters we retained. We moved them over to the right-hand side to protect that opening, and then we kind of emulated it to build a taller screen beside the bathtub. I was afraid that someone might fall out of the bathtub and fall down the stairs, so I thought that was a cautious step to take. And down on the ground floor, we're looking over the master bed. We put in a sliding door there, and my friend he built the door and made the handle for it, and it's really nice. It's quite unique. And a view of the living room. And in one spot, we had to put some steel bracing on the wood beam because we discovered the inside of the beam had been eaten by carpenter ants. So we had them removed and cleaned out and then put steel over it. So again, it was sort of like adding to the ongoing maintenance of the house, and just adds another level of richness. And the view on the right is showing you the kitchen, and the tall window is on the same line as the gable on the front of the original house. So there are points in the house where you can look right through it, because it aligns with the staircase also. In here, we used a vinyl tile, and the kitchen counter, the kitchen island came from Costco, and the kitchen cabinets came from our local hardware supplier. So it was all very local and not like super expensive stuff. We basically were watching every dollar we had to spend here. And that brings me to the end. And I hope Barry seemed to like this little house, and so I was quite fascinated with his interest, and I hope you found it interesting too. And I'd be happy to answer any questions. Thank you.
Thank you very much, Jonathan. I mean, I think there's lots of great feedback in the chat there. Lots of appreciation for you know, this project. I think it's a beautiful example of how you know, a traditional building, the character of that traditional building has been retained, but the performance has been, you know, hugely improved, and shows the versatility, I suppose, of the passive house standard, which is often criticised for you know, boxy, dull architecture, but yet you know. This is anything but. So yeah, beautiful project. Again, I would just encourage anybody with any questions just to pop them in. I've got one or two, but please come in behind me. You talked about the winter heating, Jonathan, and when you were minus 25 and using your small electric heater. You didn't mention heating generally, so can we assume that there is actually no heating system other than the heat recovery unit? Is that what heats the building?
Right. Yes, I should have mentioned that, Simon. And this is partly because we rent this house on a short-term basis, that we get tenants who don't even know it's a passive house. And so we installed a small Mitsubishi mini split, And it was very carefully installed, so we didn't damage our airtightness. It was very carefully sealed. But what it does is it just gives us that little bit of heating and cooling that are needed just at the peak of the summer, because we can hit 40 degrees in Ontario, and we get a lot of humidity along with that. And we can go down to -30, so we have a 70-degree range of temperature. Although, you know, with global warming, that's diminishing. But the mini split means someone can just pick up the remote control and get some air conditioning or get heating. And the ERV then kind of maintains a pretty good average temperature throughout the house. So that was the solution we adopted for that.
Thanks for that. John Moorhead has just asked, maybe you mentioned blue skin, which is maybe a term we're not all familiar with over here.
Okay.
He's just asking, is that a vapor control membrane?
It is, yeah. You know, it's a super adhesive, thick and very durable vapor control material. So it's really good for working around difficult junctions. And the other place where we used it was around the base of the 4-post structure, because we couldn't like cut the post or lift the post, because it was embedded in the beam, the ring beam. So we put about 6 inches of that blue skin around the base of the posts, so that if you could imagine the cross-sectional area of the post was the only part of the ground floor that didn't have an air barrier on it. So I think that reduced, you know, certainly the air pressure test showed that didn't negatively affect us.
Indeed. I think John's got another question. Just going back to the mini split, is that heating the air supply?
Yeah, that's it's got a condenser outside, and the only thing that comes into the house is the Freon, which is a liquid. It alternates between being a gas and being a liquid, and so it drives, like, in other words, the mini split inside component is just running a fan over the heating cooling coil. So there's no air. The only air coming into the house is through the Yablotron ERV. And the mini split is recirculating the air inside the house and either cooling it or heating it, depending on the season. Yeah.
Okay, yeah, so it's a kind of a separate system. The two systems are separate.
Completely separate. Yeah.
Okay, thanks for that. Shane asks if you could just explain the difference between energy recovery ventilation and heat recovery ventilation, or the ERV term, which again is probably one that we're not so familiar with here.
Okay, so we say ERV when we use a piece of equipment that can influence the relative humidity. So the humidity as well as the temperature are deemed energy recovery. So it's a subtle difference. And to be honest with you, the equipment is capable of moderating the relative humidity, because the ERV has a condensate pipe that you have to take to a drain. But the amount of water that comes out of it in the summer is not enough. At least I know this from my second house, which I'm in now. It's still a bit too humid in the summer and a bit too dry in the winter. So I tend to run a humidifier in the winter in addition. but I'm working on that with the manufacturer to see that I'm getting the best performance. It's still something, and I'm very tuned in to the pros and cons of relative humidity, because during COVID, we've learned from all the new studies being done that if you have really low humidity, you have a much greater chance of getting infected in your body. And the aerosols that carry the infection airborne will travel much further in a low humidity environment. So much so that at our office in Toronto, we installed our own tenant-owned ERV so that we could have a continuous supply of fresh air, that would run through the MERV 13 filter and give us fresh air as opposed to recirculated air.
Thanks, Jonathan. I've got a question from Ibrahim, who is curious about whether you have any numbers regarding the overheating percentage as part of the passive house criteria for the building.
I'd have to look at the PHPP we did for that. I don't have any monitoring data on this house other than the hydro bill or the electricity bill that we get once a month, which is usually about $100 or less. So it's a very low energy expense. But the amount of overheating, I'm sorry, Ibrahim, that I can't give you that answer. But if Barry gave you my email address, I might be able to get it to you.
No, that's great. Thanks. Richard Kenny asked just what was the duration of the project?
Far too long, I have to admit, because my artist friend, I would keep every weekend I'd come to the house and find him laboring over something minute. And I'd keep saying to him, it's not the Taj Mahal. Like, when are you going to be finished? And, he was just so meticulous about everything he did. But of course, it took him 4 times as long. So it was all told, we probably spent nearly 2 years working on it. And it shouldn't have been more than a year. But, this house and my other guest house, we're in a rural location. The whole county population is probably only about 25,000. And all the contractors are extremely busy, and especially since the pandemic started. So very hard to get anything done in a hurry. So we just have to be patient and acknowledge that the projects here will take a bit longer, or even quite a bit longer, but we get there at the end of the day.
Thanks. And I think final question, I'd just be interested, I suppose, going back to your first slide, Jonathan. You've been involved in various scales of passive house project, and I think certainly in the UK we're beginning to see passive house applied to all different types of buildings. I think in Ireland we're beginning to see that with the Earn campus and a few others. There's a supermarket as well somewhere in Ireland. But I'm just wondering, for what's your experience of how that transition to passive house at scale has been, either through your own experience or in terms of demand or client demand in your part of the world?
Great question, because we're all in transition on this. I keep telling people that I think passive house will be our building code within 10 years. But in Ontario, we're lagging behind British Columbia. Like, Vancouver and British Columbia is way ahead of us in Ontario. The very first passive house conference I went to in Leipzig in Germany was in or around 2016 or 17, I think. the only other Canadians there then were from BC. And they're typically in British Columbia much more attuned to the environment. I mean, it's such an amazing landscape there with the Rocky Mountains and the ocean and the forests. It's a beautiful landscape, and they're being very protective of it. I think in Ontario, our YWCA, or our large project on that slide, is currently probably the biggest Passive House certified building in Ontario, which will only be that maybe for months because there's more in the pipeline. And most of the municipalities that are building affordable housing are all now requiring Passive House, or at least net zero carbon or zero carbon ready. You know, there's so many different, like procurement is a nightmare. I've presented just on the topic of procurement at a couple of Passive House conferences to try to get those people who are in the procurement business to write the RFPs properly so that they acknowledge that Passive House has certain demands of the design team, and you know they should be submitting their credentials accordingly. But we constantly are running into RFPs, requests for proposal, where they're very vague about the sustainability requirements, and they kind of say you could do it, give us net zero or Passive House or meet some other standard. And they're all a bit different and all have different demands upon you. What we try to put forward constantly is that we're an architecture firm with expertise in Passive House, which shouldn't be confused with a standard architecture firm and a consultant that is completely separate who is knowledgeable in Passive House. I think the architect needs to have the Passive House mindset as he or she starts the design itself, so that it's not something you send off to the Passive House consultant after you've started designing. Like having a knowledge of Passive House as you design is really invaluable, I think. And we're always trying to get the contractor on board early, usually a design build or a construction management team, so that everyone's involved and they don't get scared. The sub-trades don't get scared by, oh, what's Passive House? I better add 15% to my quote. So.
You know, thanks, Jonathan. I think yes, it's probably similar experiences to what we're all seeing here as well.
Right.
Thanks very much for your presentation and for answering the questions as well. We're maybe running a few minutes behind